Everyone, good morning, greetings. This is the last day of what has been an intense and extremely informative 4 days of discussions and deliberations on vehicle dynamics. The first edition of Motion and Control, the India Vehicle Dynamics Conference, is organized by SAENIS in association with Mobility Outlook. And this event has been spread across two phases. 2 days of track days in mid-November at the iCAT Center. And this, of course, is the virtual conference spread over 4 days. The event has been supported by iCAT, Aspire, and Maruti Suzuki, and has Axis Bank, Bosch, Seat Tires, ATS, AB Dynamics, and OXTS as the key sponsors. Over the last 3 days, as many of you who have been participating in this conference have seen, we have had detailed technical presentations on very key subjects as part of vehicle dynamics. So first day, we had vehicle dynamics and parameters. Day 2, we had presentations on software in the loop and hardware in the loop correlation and virtual validation. The third day, yesterday, we had presentations made on ESP testing and validation. And today, right after this panel discussion, we have a technical session on the effects of tires on vehicle handling. So, ladies and gentlemen, today's panel discussion is on vehicle dynamics in future vehicles and its impact on road safety. And we are indeed honored to have with us Mr. Anand Bhangaonkar. He's the Executive Vice President and Head of R&D Platform and SQE at Piaggio Vehicles. During the past 26 years, he has worked in various R&D functions, primarily in the automotive and aerospace industries. Earlier, he held leadership positions in key engineering functions such as vehicle integration and validation, CAE, functional science, crashworthiness, NVH and performance, and etc. Secondly, we have Mr. Gavin Hardman. He's head of chassis design at the Center of Innovative Technologies at MotoCorp. He's an automotive engineer with over 20 years of experience designing and developing motorcycles. Starting his career at Triumph Motorcycles UK, he has been involved in developing all motorcycle types from super sports to commuters. Mr. U B Rao is head of engineering, Mahindra Truck and Bus Division. He started his career as a GET at Hindustan Motors and worked on various products like the Ambassador upgradation and Contessa. He pioneered the RTV vehicle, the successful first CNG transport vehicle on Delhi roads in 2000. Later, he moved to Teco Hendrickson, a JV between Tata AutoComp and US-based Hendrickson Suspensions as head of engineering. Mr. Amardeep Singh is General Manager, Maruti Suzuki India. He heads chassis design validation at the company and carries more than 20 years of diverse experience in chassis design, vehicle dynamics performance, setting, validation, engineering strategy, and planning. He has unique experience working as a design engineer, followed by experience in ride handling, brakes performance, and NVH. His expertise lies in chassis brake, steering, and suspension design, product development, and planning. Finally, we have Mr. Prashant Vijay, who's the DGM at iCAT and is also the convener of this event, Motion and Control. Mr. Vijay heads Certification Business Unit at iCAT, and he began his engineering career at Maruti Suzuki and worked there for 6 years in suspension, steering, road load data acquisition, and simulation. Then he worked in General Motors India Engineering for 4 years as Vehicle Performance Manager and also the Product Validation Manager, and handled vehicle programs as Program Engineering Manager. Gentlemen, welcome. Before we get to the panel discussion today, a quick reminder to all our participants today. We've got 5 experts from different stakeholders, very critical stakeholders in the Indian automotive ecosystem. Do not miss out on an opportunity to ask them questions. As we go along, please continue to keep sending your questions, and we will take your questions towards the end of this discussion. So, gentlemen, like we have been discussing in the past few days, I would like to start this discussion with your initial remarks on the subject. We can keep your initial thoughts to about 2 to 3 minutes before we get into a moderated discussion. So, I would like to start off with you, Mr. Bhangaonkar. Your initial comments on the subject, please.
Thanks a lot, Dipanshu. I would really appreciate the organizers of this committee that they have invited and given us opportunity to learn and share during this conversation that we have. And last 4 days, 3 days were also very excellent. Having said that, let me just share few cents of mine right today, and then we can take this conversation forward. The global product development, be it the pass cars or tools or three wheels, have a challenging situation to meet the individual market needs, wherein the roads, driving conditions, terrain, and weather is completely different. And that's where when we are really looking at a vehicle dynamics perspective and the customer's expectation from the vehicle ride and comfort is completely different. And this is where, as an R&D stakeholder, it is an immensely challenging situation to understand and meet those requirements. Vehicle dynamics definitely is a vast subject, vast topic to deal with. There are multiple systems involved, and this is the system which would be evaluated both objectively and subjectively, and then eventually we do the trade-offs. At times, objective data really indicates that there is a significant improvement in our overall vehicle suspension or ride and handling quality. But subjectively, if it doesn't fail, we all have to go back to the drawing board, again, revisit and fine-tune our solutions also. So this is where it is, I would say, function science also, and is an art also. Vehicle dynamics is an art also equally. How to tune this, right? And because while in the initial phase, when we talk about target setting also, there are a lot of trade-offs while we used to either the vehicle should have a better ride and comfort, or handling, or NVH, or overall the steering performance also. With all of this, I would say when we talk about the trade-offs or the kind of meeting all the ride and handling requirements or any other characterization, there are multiple systems which actually delivers the overall vehicle dynamic performance, wherein there is a suspension which comes into play, then there is a steering system which comes into play. Tires are actually the biggest, they have to play a big role here. When we were developing, especially I would like to share my past experience, Jeep Compass for India, because it is a global product and developed for a global market. But when we talk about Indian market, it was a complete different animal to deal with, right? When it comes to vehicle dynamics perspective, because when I started setting the targets, right, the first one would come to a tread wear, or the primarily the durability of the tire, and then eventually the ride comfort perspective. So, and when I talk about for my other counterparts, there was, okay, which kind of tire that you're really looking for, whether it's an all-weather tire that we need to develop, or primarily a only the 3-season tire, and then you should have a winter tire. So primarily these are the different development elements of our overall vehicle dynamics as a function science that we talk about. So as far as the suspension characterization, if I have to really deal with, primarily if the ride or the comfort is my primary goal, then there would be trade-off in handling. How we don't want, actually then we kind of have achieved a good trade-off between the two by using either the FSDs between the front and rear, right, where the frequency selective damping that we adopted for both, so that whenever there is a comfort, right, and when the suspension is moving at with around ±10 hertz frequency, then you really need the low damping force, right? And when you are going into the handling element, when the suspension is really operating between ±1 hertz, then you really need the higher damping force. So those we achieved with FSDs, even and then come to India, roads conditions are different, even the speed breakers are different, and those would deliver the different experience to the our end consumer, and how to deal with that also. At times when you have tuned the suspension for a good handling element, then at times you will feel that the rebound is so harsh that at the steering also the driver would feel, or even in the rear passenger would feel that rebound, and then there would be either a tapping noise or there would be a harsh element which will come into picture. How to deal with that also. All of these elements we really have done. Steering also, at times the few people would like to have and understeer, and it should be linearly placed so that I will always have the feedback coming from the road quite well. Right. And the torque building also happening, right? So with all of these elements, this is why it is a function science and art that if you put together very well, the best product comes out. These are my few cents on this topic.
I mean, it's a great, I mean, it's good you talked about vehicle dynamics being, of course, being science, but also an art, wherein you have to get the proportions right, correct?
Actually.
And you also talked about understanding customer, expectations. That is important, right? So I'm going to bring that to the discussion a little later, but on to you, Gavin, your initial comments.
Yes, thank you very much for inviting me, and thank you very much for the rest of the panel as well. I'm really looking forward to hear what they have to say. Very interesting comments from Anand. For me, vehicle dynamics is a critical element in two-wheeler design. The motorcycle is constant. It's very rarely in a steady state of vehicle dynamics, you know, even less so than a four-wheeler or a three-wheeler. So that we get the vehicle dynamics right is critical to the user experience, because the user is constantly experiencing it, you know, everything that we've designed in terms of the vehicle response. So when we think about the title of this panel, you know, the future vehicles and impact on road safety, my thoughts are that there is the opportunity in future vehicles to have a lot more electronic interventions. But the key is to ensure that those are implemented in a way which adds safety and improves the user experience, but doesn't negatively impact the rider experience, which is possible with some of these features. And the other thing, and I think Anand touched on this, is that a lot of the advanced technologies which are spoken about today, you know, if we're talking about lane change, blind spot warning, adaptive cruise control, etc., adaptable suspension, these are very often developed from a European or a US perspective. And actually, I feel that a lot of them are not really yet ready for Indian road conditions, Indian driving styles, lots of you know, the huge change in the difference between where those products were developed and actually applying them in India in a way that really adds value for the customer. So I think that the trick for us is going to be to take the right bits of that knowledge and the lessons learned and apply it in a way that really adds value to an Indian customer, where possible, an Indian consumer. Learning from things like, you know, the lessons learned with ABS and behavioral adaptation it hasn't actually made a massive improvement in motorcycle safety, which is a real surprise, I think, to everybody who's put a lot of effort in. Because people just ride different now, you know, so the actual numbers don't change very much. Cost of the systems, that, you know, this is going to be critical. We have to develop systems in India which are for Indian road conditions and Indian customers and Indian economics that can actually be implemented in a way that gives the best impact for all road users. You know, at Hero, we make vehicles for you know, everybody, every man, and we should be able to give those safety and vehicle dynamics improvements to everybody. That should be our target. I think one area which is really exciting, which is coming to the fore now, is connected vehicles. So we know that a lot of vehicle safety is for motorcycles is actually down to being involved in an accident with another vehicle, hit by another vehicle. You know, all the statistics tell us this. So connected vehicles potentially offers us a really great opportunity to warn those other vehicles of our presence and to actually passively do something about our presence, you know, and make those other vehicles or our vehicle react to the relationship between the two vehicles. And our job really is to ensure that we're ready to tie up with 3- and 4-wheeler providers, and that we implement the responses to information gained through connected vehicles in a way which adds safety and doesn't negatively affect the customer. So quite an exciting time. We also have electric vehicles on the horizon, and that provides us with another challenge as well, which I'm sure we'll talk about throughout the presentation.
Super. Thanks, Gavin. Thanks for your initial remarks. I mean, some of the subjects that you've already touched upon are very, very critical in the Indian context, right? One subject that I definitely like to come back to our panel today is about the cost, right? Technology and at what cost, right? So I'll come back to that later. Mr. Rao, over to you, your initial comments. And here we would like to understand from the CV perspective.
Thank you, Deepanshu and other panelists. Thank you very much for inviting me to share my thoughts on the how we deal with the commercial vehicles, vehicle dynamics. So, as we all are very much aware, like it is a good trade-off between the ride and handling. Okay, in particular, of course, all vehicles, all automotive. However, in commercial vehicles, that is a very good trade-off, more than anything else. And the kind of variants we have in the commercial vehicle and the kind of the variants in the number of tires and trailer combinations, whether it is a two axle trailer or three axle trailer and everything. So it is a kind of very complexity which we have to address in the market, and it is a changing scenario and a day in and day out kind of thing. So when we used to design earlier days, we used to deal with the kind of yaw rate and then roll rate and pitch and everything, come out with some trade-off and then get going. But kind of scenarios which are emerging, and particularly like e-commerce, okay, this evolution, and then it's a kind of explosion in the e-commerce where tap time, I mean to say the turnaround times are very important, and then and the infrastructures are developed very well, and then where commercial vehicles used to run at 40, 50, 60 kilometers, now they are running at the maximum speed of 80. And then as we go forward, certainly we expect that they will touch to the kind of European speeds or US speeds. So the kind of Mr. Nitin Gadkari, the way he is developing the things, we are ready for that kind of infrastructure where we can drive our commercial vehicles also at more than 100 kilometers per hour. So there it's really comes into the vehicle dynamic controls, which are already being used in like passenger vehicles. Okay, those are all vehicle dynamic controls can come into handy, but we have challenges. Like I have explained that the variability on commercial vehicles are very high, in particularly heavy commercial vehicles. And in particular in heavy commercial vehicles, I can say there's a tractor trailers. So that is the one area, it's a big challenge. How do we adopt the same thing, whatever is there in the passenger vehicle? There are challenges. And plus, as Gavin mentioned, at what cost? Because commercial vehicle operator looks for the cost of ownership.
Absolutely.
Okay, so that's where exactly we need to see that how quickly we can bring that some frugal solutions, which will address the cost of ownership of the end user and then owners. That is where I say that my initial comments, it is onus is on us to bring the frugal solutions before really jumping into the kind of technology available. Okay, yes, at an appropriate time, we have to bring in, there is no doubts about it, but at what cost and then who will afford to do that and everything. But we have to bring some frugal solutions. Okay, before we getting into everything. So that's what I would leave it at this point before we go into detailed discussions.
Thank you. Thank you. So focus on frugality before we look at high-end technology solutions for the Indian market. Amardeep, I'll come to you as the biggest, largest manufacturer of vehicles in the country. How are you looking at future vehicles and vehicle dynamics?
Thanks to give this opportunity to talk with such experienced panelists. So before I begin, I would like to summarize what Mr. Anand, Mr. Gavin, and Mr. Rao touched upon. One thing was very clear: the industries are different, but the language of vehicle dynamics is same. The challenges, what they expressed, the experiences, and everything is very in cohesion when we talk about the field of vehicle dynamics. So I will try to touch upon a little bit about the future as the current was very well expressed by Mr. Anand, what are the challenges we are getting today and how we are dealing with them. So when we talk about future, if we just have a small look at the past, because that gives us a very good opportunity to understand how the future can be. So the whole concept of a self-propelled vehicle was started in 1600s, that is centuries before, with the steam engine concept. And the actual mass production vehicle came into picture maybe I think 1908 or something, with Ford coming into mass production. So that journey of 2.5 centuries compared to what we have achieved today in 2021 with respect to when we started the automobile industry, it is a tremendous change. The changes are big. The evolution is very fast as compared to earlier. The computational powers have increased tremendously. Simulation, which started on paper, then to some CAD tools, today is supported by artificial intelligence. So the amount of changes expected in the future are going to be at a much different level. So coming back to vehicle dynamics, the way we deal, as we all discussed, that it's a balance between ride and handling, because the physics of both goes in opposite directions. But the way we will look into vehicle dynamics in coming future will also change. Earlier, when we started our career, most of the things, I started my career 20 years back and have seen tremendous changes in vehicle dynamics in the last 20 years. Earlier, it was all mechanical. So the decisions were mechanical, the tools were mechanical, the inputs we were receiving were mechanical. But now a lot of electronics has come into picture. So the way things will happen in future will definitely be different in perspectives. But the challenges will remain same. When we talk about India, the robustness requirements of our country, the varied type of road environment, the varied type of customer environment, the cultural differences we have are definitely going to pose a big challenge in the future as well. And as I think Mr. Rao rightly said, that there is a technology and okay, it's one aspect of implementing that technology in our context, but that may not work because we have to talk about the cost also. So how well, so we have to make a balance that what technology at what cost we can implement. And there comes the engineering mind, the people, the youngsters who are working today in the industry, in the vehicle dynamics, they have to think about it, that how we don't have to think very complex. Our requirements are unique, our challenges are unique, and our solutions can be unique. The way forward, what I see is that even the young engineers who are entering into this field or who are already working in this, we have to be very, very interdisciplinary as well. So not only the mechanical engineering knowledge, the knowledge about electronics and other disciplines is also going to play a key role if we want to have a unique solutions for our country requirements. Way forward in today's panel discussion also, we will discuss about how the challenges will be there in the conventional vehicles, in the EV vehicles, and of course the hot topic of the day worldwide, that is autonomous vehicles. So what form of autonomous vehicle is going to be suitable for India, and how are we going to progress forward in that? I think it will be a very interesting talk today. So we can move ahead and let's explore more about it.
Sure. Thank you, Amadi, for bringing again a very critical subject of interdisciplinary knowledge for engineers going forward, looking at the evolution of the industry as well as the complexities that are sort of coming in. So I'll move to Prashant now. Prashant, your perspective on the subject today from your area of expertise, homologation, certification. Yeah.
So thanks, Dipanshu. And it becomes my area of expertise recently, but I started with the field of suspension, chassis and steering. That was my first department when I was in Maruti.
Right.
And I can still recall that the first time when we tuned the Swift for India. So I was one of the core team in the suspension tuning part. It was a very tough task. Even the speed breaker challenge, the variable stiffness was the challenge at that point of time. Then further, when we went to GM, I got more explore under the GM Devu testing training for the ride and handling. There was a big challenge to tune the suspension as per the Indian requirement. But the major area at that duration was related to ride and comfort, as said by other panelists also. But if we look at the today's trend, I can see there is a demand and we really need a good vehicle dynamics. If you look at the power is increasing of the vehicles, and we need a good mechanism to handle it, because power, if cannot be handled, will cause a disruption. So to handle, we need to have very good control of the vehicle, which comes under the vehicle dynamics part. If we look at the infrastructure, the roads are the quality and the things are increasing. So again, there is a big need of improvement and demand expectations of the customer in terms of vehicle dynamics. From the two-wheeler, from the four-wheeler, now, like in the regulatory aspect, if we look at, there was an implementation of the ABS, which was mandatory into the trailer system. We all have seen the trailers looking like such a, just a metal sort of thing for normal people. But if when we came to know that, okay, the ABS is mandatory, and initially there was an inertia from the people to accept that, because kind of loading is being happening onto the trailer and other things. But sooner, progressively, if we can see, the demand is increasing. People are accepting that because it is giving the other benefit in terms of tire life, in terms of other factors into that sector. And even if you look at, the government is now putting more regulation which are linked with the vehicle dynamics. The ESP is one which is introduced into the regulation. Even few people I have seen, they are adopting these things before the regulation has come to make the effectiveness, to make more usable their vehicle. And this is what the things are going on. So my main thing is, now the customer is aware. So of course, challenges are there. And if challenges are there, we will definitely find the solutions also. But the requirement of the things for the high dynamics perspective, whether it is the braking system, whether it is the handling system, whether it is the steering response under the various maneuvers. So all are now the need of the time. People are aware, people are sensitive towards these things. So we definitely have to work and excel into this domain. So that's what I would like to say this time.
Thank you, Prashant. I mean, there must be challenges for engineers to work on, right? Only then you will come up with solutions. So that's a fair thought. So I mean, when you look at what all of you have sort of brought into the table today, and like Amardeep very clearly said, that things might have changed, but the challenges across sectors have remained the same, right? The challenges are common. So when we look at the evolution of the mobility sector, right? I mean, we're talking of course, conventional vehicles that continue to be the core of the Indian market, but we are looking at a very strong and very fast evolution into different mobility trends of the future, EVs in particular, and autonomous in the future. So I would like to understand from you, Mr. Bhangaonkar, when we particularly look at the evolution that you see in your sector, particularly, what are the kind of changes that you see coming in to vehicle dynamics?
Okay. As you correctly pointed out, now I will come back to the last mile mobility, shared mobility, or goods mobility, what we are into, which is our three-wheel business also there, right? Post BS6, now we are looking at all the EV and then multiple products that we have launched in the marketplace. While doing that, if I really look at all our products, right, electric vehicle, to reduce the losses, we were looking at a lot of low RRC tires, right? We were looking at from the motor to all the way to the tires, so that entire efficiency loss in every system can be reduced, so that we can get the best performance from the range perspective on the EV. When we talk about the tires for the segment that I'm talking about, three-wheelers, wherein till today, all the tires in the 8-inch or 10-inch, those are cross-ply, right? That itself is the big negative part from the EV perspective, because that would create the greater loss. And this is where now we are looking at the green tire development and then low RRC development in that size also, because the customer needs, it doesn't mean that, okay, 12-inch or 14-inch tires are there, which are into radial form with much low RRC for EV, can I adopt it? The answer is also no, because the segment that we are in and what customer that we are talking in, they're very comfortable with the same size. And that's where it was challenging while dealing with the electric vehicle. Then when we developed the low RRC tires for that size, 8-inch or 10-inch, our brake performance was again a big trade-off. Right? And that's where it was a challenging situation to deal with. Overall, EV vehicle, our weight distribution and CG have changed compared to the earlier IC engine scenario. And that's where, from the handling perspective or even the lateral and cornering perspective, we ended up working on those areas quite significantly. First of all, from four-wheel, when you take out one wheel, that itself will create a lot of instability in the product. And to make it further worse, when you evolve from IC to EV, with all of these different weight distribution, it was a further challenging for us to tune both front and rear suspension and look at even the tire tuning part of it also.
Right. So very critical points again. Particularly, I like your point. Thanks for pointing out the fact about tires. The kind of changes that tires would have to see as we move ahead. Gavin, coming to you, when we look at the two-wheeler segment, I mean, in your initial comments, you did talk about certain the electronic interventions coming into products now, right? And when we particularly look at the future, we talk about advanced rider assistance systems, right? But are we ready as a market to adopt such technologies, considering the cost, of course, which you have already mentioned? How do you look at this whole evolution happening in the country?
I think that it's a big question, and it's a big question for the suppliers of these systems as it is for us as OEMs. Maybe if we'd been in the same situation 10 years ago when we looked at ABS, we probably would have been saying the same thing. It's too expensive, the Indian customer doesn't need it, etc. But actually look now that, there has been legislation passed, and that's forced industry to, really aggressively look at the cost of the systems, develop simpler systems which can, which size-wise, cost-wise, complexity-wise are suitable for application. So I think we're a long way from it with some of the ride assists, but then you have to start somewhere. So, but I do think that we need to be very careful to pick the right technologies for the customer and for the road conditions, and then start to look at those technologies and how we adjust and adapt and drive down the cost of those technologies. And actually, another thing that I would like to see is that rather than just taking the technologies which have already been developed, such as lane change, for example, start from a clean sheet. Think about, what does the Indian customer need? What would be the most effective intervention that we could make for the Indian customer, and then develop systems from there. And I would really love to see Indian suppliers and Indian, technologies. Software is the great thing about this is that software is an area where India is really incredibly strong. So it should be somewhere where perhaps you have that advantage. We have that advantage to develop those technologies. So yeah, I've talked around the subject a little bit. I think the honest answer is that we don't quite know yet, and that the work is required to really analyze what's available, what's achievable in the next 5 to 10 years, and what would be most effective for the customer. But
are you, as an OEM in the Indian context, sort of happy with the progression that we're making as a country from, let's say, one channel ABS to 2-channel to going into other more advanced braking solutions?
I think there is probably a big step now before we move on to the two-channel is pretty straightforward, and then there's pressurized systems, and then I guess there's cornering ABS as well. Those kind of things, I could see us slowly making the step, but I'm not sure they're all required all the time. The next step I see as being quite challenging, because the amount of addition to the vehicle that is required for anything beyond this is huge. If we start adding cameras to motorcycles, the cost of these systems is at the moment a long way away from what's possible. On premium vehicles, of course, it's possible because you have much more scope to, a much larger bill of materials cost than you can, and the customer's willing to also shoulder some of that extra cost to take the technology. But moving that from that point down to something that we can fit on everyday vehicles is going to be a real challenge. Possible in some instances, I'm sure it must be, but we have to, as I keep saying, we have to find the right ones and then concentrate on driving those in the right direction, cost-wise and complexity-wise.
Sure. Thanks, Gavin. From two-wheelers, I'm going to come to four-wheelers. Amardeep, on to you. When you look at the evolution of the passenger vehicle sector, particularly, ICs to EVs, and then, of course, to autonomous vehicles. How do you look at this? And from a readiness perspective, where is India today?
It's a very interesting question. When we talk about the evolution, which is like happening or going to happen, so today we are more into conventional vehicles in India, and the progress will be towards EV or whatever alternate technology. Something will come. We may not be very sure today, and the way forward will be even autonomous vehicles and other things will also fall in line. It's a matter of time. But if you talk about the progressive steps and how India is prepared, one thing on the positive side is that we have so many, as we all discussed, local challenges. The problems which are forced upon the Indian engineers are much more interesting in some ways than worldwide. So that adaptability and transformation will always be a key maybe strength of Indian engineers way forward. Technology may be developed for some complex solutions. We will learn how to adopt those technologies for our localized problems in coming times. For example, going towards EVs and other technologies, a lot of sensors and other things are coming. So a lot of things depend upon the supplier base support system also, how we are able to manufacture them in India at a lower cost. Software, as Kevin also said, is one of the strength of India, even today, in the past also, and the way forward also. So when we talk about the software assistance part, that definitely is a picture which we can clearly say that we will be ready with. On other aspects, what I will say is, especially because today we are at a vehicle dynamics forum where a lot of test engineers and designers are there. So what we should do is that we should always, increase our understanding of the customer and maintain our understanding on the technology which is coming. And try to improvise the things to find solutions of what we are facing today as challenges. So as Kevin also stressed that we have to find unique ways of using these technologies. See, sensors are sensors, they will give some input. Sure. There is a cost associated with them. But what you desire may not necessarily require a high cost sensor only. For example, in India, the road infrastructure is a challenge. So potholes, speed breakers, and speed breakers are also of different designs. So when we do ride handling and all other things, it's really challenging. And in Maruti, we try our best that we reach the masses and we balance out between handling and ride. Sure. So just giving an example how technology can be integrated in future. So one thing is that we have sensors which find out pothole is coming or speed breaker is coming and take intervention according to that. A simpler way of that can be like India being a tech savvy and software savvy. Almost everybody in India is having a mobile and a Google map in their hand. So if we are able to predict something like a pothole is coming after a few meters or something like that through softwares also, and the customer, the passenger is the driver is given an input that please slow down. So those sort of low cost interventions may be the way forward for India rather than putting a lot of sensors and a lot of cost in the vehicles. So that may be one sense of it.
Right, Amardeep. But having said that, Prashant also did mention in his initial comments that our road infrastructure is improving, right? So that is on a positive note. Mr. Rao, I'll come to you. Amardeep did mention about, when he talked about cost of sensors, he essentially talked about a point that you had made earlier, right? Frugality in the Indian context. Now, when you look at the complexities of commercial vehicles vis-a-vis, let's say, passenger vehicles and other forms of vehicles, what sort of evolutionary changes do you see coming into vehicle dynamics in the years to come?
Yeah, it's a good one. So the kind of evolution which is going to come, kind of what I mentioned was that whatever is readily available with passenger cars. So these are all can come to commercial vehicles. However, it will come with the cost. Hence, when I mentioned that frugal solutions, we need to see that which are the low-cost solutions which can give the similar kind of, it may not be give the same kind of controls, but it will be similar kind of controls in the Indian scenario. So if you consider the Indian drivers, in particularly commercial vehicle drivers, they are very highly skilled compared to any other part of the world. And like other part of the world, they go by the rule and then drive it. But in Indian context, they drive it with the skill kind of thing. They knew that what is going to come and then at what turn they have to take the speed and everything. And then what kind of brake steer comes. And then they could assess a lot of things by virtue of their experience. So we need to give the kind of things like sometime back we talked about the ABS in the trailers. So that really helped the industry, because in trailers, typical vehicle dynamic issue comes with that when you apply the brake, that kind of jackknifing comes, which kills your trailers.
Right.
Okay? So that's where exactly we could come out of that issue with the ABS. Now going forward, next big challenge is that the variability in the CG of the things. When we are talking about the vehicle dynamics, we need to talk about the roll movement and then roll gradients. Okay, so if we address the roll gradient and then roll moment by altering the CG of the vehicle in dynamic conditions. Okay, so how do we do that? Those kind of things we can make use of the technology available in the system today, where connected vehicles are very much in the system, like vehicle tracking systems. Okay, and then there are each and every vehicle now with the vehicle tracking system in a commercial vehicle. And at Mahindra, we have developed the kind of vehicle health monitoring system, which is called IMAX brand name and then my name. And then it can monitor the vehicle kind of even what kind of GVW it is running, and then at what power it is running, what speed it is running at particular moment. And then we can predict at the back end, it gives the calculations and tells the like we are using the kind of ADAS technology to give the driver assistance. Suppose if somebody loads the kind of, I'm giving the example so that it gives the right perspective. When somebody loads the kind of goods at which increases the CG of the kind of thing, then it will assess that whether CG is increased or not, and then it throws the driver saying that he has to reduce the speed. Okay, that kind of driver assistance systems we have to use it. That is the frugal solution than the kind of other VD controls, like vehicle dynamics controls. And another thing which it comes is that we need to work on the kind of trailer suspensions. I mean, the trailer suspensions, if we make it kind of pneumatic, so through the connected vehicles and then the vehicle monitoring systems, whenever the CG goes up, you can lower the height of the goods by lowering the platform height. So these are the frugal solutions. Of course, this will also come with the cost, but not at the cost which vehicle dynamics controls are there.
Right.
So these are the kind of things. And another thing is that you see that another vehicle dynamics which we face the challenge is that the steel coil transfers. Okay. So typically if you see that Europe and everything, and trailers are made with the wedges so that entire coil sits in the wedge and then entire CG is down. So that's where we got to focus on that when I mentioned the frugal solutions.
Sure.
Yes, we need to make use of the VHMS, vehicle health monitoring systems, and through the connected vehicles, and then driver assistance systems. So this will give that. Yes, when we get onto the high speeds more than 100 or 120, certainly there are regulations are going to come in the kind of AEBS, like autonomous electronic braking systems and ESPs and everything. But this ESP and everything, it is more appropriate for the passenger vehicles like school buses or staff buses and all. Whereas VHMs like ESPs, like electronic stability controls, may not be right at this moment for the heavy commercial vehicles. At the same time, AEBS, advanced electronic braking system, maybe it is required later stages, not at this point.
Not at this point.
So that's where I see that when we get into that, our engineers get into the systems where they can look for the solutions very frugal, and then it will give the similar impact in Indian context. That's what I said.
Thank you. Thank you for giving us a comprehensive understanding of how you look at the commercial vehicle sector sort of evolving. Coming to you, Prashant, I would be keen to understand from you the future approach when it comes to testing. When we look at technology as well as the methodologies used, how do you see this evolving, considering the evolution of the overall Indian automotive segment?
Well, it's testing per se. Definitely, there are new technologies which are coming, new equipments which are coming, and people are getting trained into the India. If you look at any new regulation, we don't found the trained people. We have to take help from someone outside, or at abroad to get trained onto the equipment. But my main thing is, because the things are coming, the requirements are coming, and we as an Indian industry will have to evolve ourselves. Initially by adopting the technology, but later is a part of localization also, which is government is focusing through various schemes. So we have to develop our own capability. And one big things which I found is lack of information, which has we always rely on to the data which is acquired on other countries, not in India. Because in any regulatory forum, whenever we make the rules, we don't found a suitable data. We say that, okay, it is the Indian condition is like this, Indian condition is of this type, but we don't have any properly database sort of thing or information in that regard. So we just have a argumentative point of view. Yes, this is the condition like this, and accordingly we try to adopt or modify or prepone or postpone the rules which are already there into the outside the world. So my point is that we first have to work all our OEMs. Now they are well equipped with the equipments, and we have to make our own database in terms of usage of the customer, in terms of our driving practices. Like they said, the Mahindra has done all the theory, all the results, how the CG is changing, how the driving pattern is there, all those things. So this kind of data is very much required to make a suitable rules and suitable guidelines for Indian conditions. Because we cannot drastically change our patterns, our working style, our culture. But according to that, we have to make the technology, we have to make the rules which are more towards make the things safer. So this is what I would like to say onto this comment.
Thanks, Prashant. Gentlemen, I'm going to come to the second phase of our subject today, and that is to do with road safety, right? Now, what is the key role of, let's say, vehicle dynamics in road safety, specifically in the Indian conditions? Let me start off with you, Mr. Rao, your comments on how VD can actually be an enabler. And Prashant talked about data. So data, of course, become extremely important, right? When we're talking about bringing in better safety solutions. So what are your thoughts on this subject?
You see, road safety on the vehicle dynamics, vehicle dynamics, how it will help the road safety. So when we start designing the vehicle and everything, we consider all the parameters, and then we take care of all the requirements, like what I mentioned, that ER rate or roll gradients or everything. But the kind of suspensions we design, which is the key for the one of the key parameter besides the handling, is that we take care of the lot of roll things by designing the various methods. When you do that, even bush in the leaf spring, it makes the sense to avoid the roll. Okay, and shock absorbers, when we fine tune it, you see that roll is in the perfect, like balanced very well with the handling. And then what happens is that, like when we launch the vehicle, things were very fine. But with the lifespan of the vehicle, what happens is that in the typical commercial vehicle, many people, they don't replace if shock absorber fails. Or they will go to the kind of roadside shop and then buy the shock absorber which fits into that. That's right, exactly. During the life cycle of the vehicle, this safety is the concern. Okay, and at the same time, when we are designing the bushes or something, like we generally design it for the kind of life at some cases, but sometimes it is not possible to design for the life. But when we buy the bush, if they don't come to the dealer and then don't buy the bush, which is for the suspension, so they buy from the market, it will have the different characteristics. Hence, it's that vehicle dynamics characteristics will be it will be tapered, and then it won't work. So that's where exactly we may have to have the kind of solutions for the young engineers. They look for the any suspension or handling systems designed for the life. They have to innovate and then see that how to do that, and they have to differentiate between the load characteristics and then handling characteristics. So whatever is parameters are applying for the handling characteristics, they should design for the life. And then whatever is applicable for the load carrying, that can be replaceable at the intervals, because that will not help much in the vehicle dynamics. So that is another thing. Another thing is that the kind of like when we give the authorization to the parts, spare parts and everything. So that's where exactly it makes, we have to put the right processes to get the right things in the spare parts also. That is possible in our dealerships, but offside it is. So that's how in the commercial vehicle dynamics, really it's a safe in initial stages, but during the lifespan, it is a big thing. It is a challenge. That's what just I want to put my point.
Sure. Thank you. From multi-wheels to coming to two wheels, right? Gavin, we are aware that two-wheelers account, I mean, India overall accounts for 1.5 lakh fatalities every year. I mean, that's extremely high compared to other nations. And two-wheelers account for the most number of accidents. So when it comes to road safety, and particularly when you talked about safety vis-a-vis two-wheelers, what do you think can actually make vehicles safer on Indian roads?
When we look at those statistics of, it's absolutely right that motorcycles make up a disproportionate amount of accidents and deaths. The statistics show us that actually most of those accidents are caused by being hit by another vehicle. Right. And actually motorcycle speeds are relatively low. So a lot of the interventions in terms of ABS, etc., these are not the ones actually that I would prioritize. I would prioritize things like conspicuity, things that help us be seen better by other road users. Anything that helps us, maybe ABS is helpful when another vehicle is involved if it allows you to react faster or use the braking system to its full effect. But actually, what I'm really, really interested in is connected vehicles and what that could do for us. So, for example, if Mr. Rao was to put in his trucks some warning system which could tell him that there is a motorcycle to the left when somebody's going to turn left, etc., and have some kind of warning beacon, and we would have to have some kind of sensor on the vehicle. Those are the kind of interventions that I think that could make a huge difference in India in terms of.
Okay. Sure. So there's a case for vehicle-to-vehicle connectivity, or even vehicle-to-infrastructure connectivity in the long run. And as the industry evolves, I'm sure we're going to see some of those solutions coming into the market. Amardeep, on to you, the subject of road safety, and how do you sort of get vehicle dynamics to sort of improve that situation in the country? You're on mute, Amardeep. You'll have to unmute yourself, please.
Yeah, I'm sorry for that. Okay. So when we, like today is a very unique forum where, vehicle dynamics is being discussed in different paradigms. So I would like to touch upon that the very, like Raman-san also in his initial speech has told that when we talk about the safety of the cars, so vehicle dynamics is the very base of the entire pyramid, where a lot of onus lies on in terms of safety and experience of the driver. So when we talk about vehicle dynamics, even SAE definition of vehicle dynamics is that handling is basically safety in moving, safety in motion, and braking is safety in stopping. So definitely vehicle dynamics is the key role when we talk about safety. So here as a test engineer, as a design engineer, it becomes very, very predominant that in whatever infrastructure or whatever technology in hand we are working, we are tuning our vehicles very aptly so that in the diverse situations where a driver comes into a situation which is very critical and can lead to a crash, your vehicle is stable enough. It is very predictive in nature, and he because every driver does not have a skill of a racing driver. So the vehicle has to be very predictive, and he should be able to control the vehicle in a manner which does not lead to fatality. So that is the basic, very fundamental role of vehicle dynamics. Of course, then the technologies of ADAS and sensors and everything are going to be built upon that. So for India, considering the market requirements, infrastructure, the paying capacity of our customers, we are very, very cost sensitive market. And that is why it becomes even more important that we work more on the fundamentals and then evolve for the future. So when we talk about the fundamentals, there are many young engineers also into this field. So simulation has played a very important role. So simulation and testing as a joint thing is evolving very fast in India. In my personal career of last 20 years, the tools in our hand, the facilities, the machines have evolved in India, and in many aspects in the testing world specifically, we are at par with the facilities worldwide. So if we have that power in our hand, and if we are able to better fine tune our vehicles and use frugal technology, as Mr. Rao has said, so that is the way forward for India. Of course, in the future, when we talk about, or worldwide, even when ADAS and fully autonomous vehicles are being talked about, even then vehicle dynamics plays an important role. Because when you are giving a fully autonomous vehicle, it will only be comfortable for the customer under driving conditions if there is the yaw, pitch, and all those things are sorted out in the vehicle. Otherwise, a fully autonomous vehicle is also not going to help.
Right.
So that is the way forward, and definitely the base of the pyramid has to be strong, and it's a long way. And in India, we have to be putting more efforts on the basics.
Excellent. Gentlemen, we are 2 minutes away from the closing time, but what I'm going to do is I'll try and we have some questions coming in from our delegates as well today. So I'm going to try and take a few questions from the attendees today. One is by Mr. Mandeep Singh. He says, talking about the safety features like ESP and ADAS that are currently there to support safe driving to customers, how is the industry working to make the Indian customers aware and friendly with these features, as these are completely new to Indian customers? Mr. Bhangaonkar, would you like to take that? He's talking about building awareness about safety features and how critical that is.
It is extremely critical, because all of these new technologies, when we started incorporating in the vehicle, making sure that our drivers are educated to handle these also, as in the previous topics also, as we talked about, the overall vehicle speeds have increased. So when you are getting into that kind of a vehicle, then it is immensely important that you are completely educated to handle that, and the supportive or enabler system that comes with those products, you should be completely aware to get the best performance and safe performance on the road for yourself. Right? And there are a lot of good features which are coming in, and even the what you just mentioned, those definitely, as customers, that they have to get used to. And then even I would say in the electric vehicle also, it has happened that the way I used to drive my regular IC engine vehicle versus an EV, you have to completely have your mind as a clean slate and try and understand this vehicle, and then only you can get best out of it. Similarly, all these vehicle dynamic systems also, you have to really be educated. It is the onus on all OEMs that we need to educate to all the customers when we are handing over this piece of vehicle to all our customers.
Right. I have a question from Abhishek BS. He wants to know, are there any standards that specify the stiffness range to maintain in the chassis frame? So Mr. Rao, maybe you can take that, and I'll also come to Amardeep on this.
You see, there is no straight question, straight answer to this. Like the stiffness of the frame, it goes with the kind of load and then kind of span it is available. It is to do with the vehicle dynamics, where you need to decide on the torsional rigidity, which will control your roll moment and then roll gradients. So you cannot make it high stiff frames, which may do very well in the straight road conditions, but when you take the turns, so it will not give the enough flexibility to come back. Like when you oversteer or understeer, conditions will vary with the stiffness of the frames. So there is no straight or any kind of specifications for the stiffness. It goes to vehicle to vehicle.
Okay, all right. Amardeep, would you like to comment on this? You're on mute, Amardeep.
Yeah. So there is no specific standard today to define the torsional rigidity, if you say. But definitely there are standards on the measurement method. So there are standards which define, especially in the passenger car. I'm not aware how about in the truck industry, but we have very well-established standards where we can, the complete definition of torsional rigidity and how to measure it is there. Of course, when it comes to the targets, the target of torsional rigidity very much depends upon what project you are working on. What is your benchmarks in that area? What are your safety criteria? So those things are very much based upon the category of the vehicles and other things. So standardization of measurement is there, and then it becomes your experience and your targets which define the torsional rigidity.
All right. All right. Thank you. I have a question from Anbaras and Mani. Mani wants to know, like ABS, will traction control also become a homologation requirement for two-wheelers? So Prashant, would you like to take that? And I'll also come to Gavin with that question.
Yeah, maybe currently there is no discussion into this way. Still, we are working more onto the ABS part, because that is still being adopted, not adopted in all the level of the vehicle, because it is a big part of cost also. So maybe sooner if we progress and the more kind of high vehicle dynamics, high end vehicles will come, which are people are liking that. Those are also coming lots into the market. It may come, but currently there are no discussion in this.
Okay. All right. So Gavin, in addition to this question about traction control or importance, you could comment on that as well. Deva Ranjit wants to know how extensively is getting feedback from driving simulators preferred in India. I mean, do you, in your R&D process, what is the kind of importance you give to driving or riding simulators?
I suppose it depends what he means in terms of simulators, which a person can actually sit in and simulate the experience. We very little in our R&D, quite honestly, because the motorcycle is such a dynamic vehicle that it doesn't really make sense at the moment to do that. Simulation is a growing simulation of vehicle dynamics is obviously a huge area that I'm sure everybody is working on and continues to grow and be, as we get good correlation and as we get faith in our results, we implement it more in the development process. But there'll always be a mixture between rider and simulation, because I think someone commented earlier, you can never quite beat the subjective analysis of a person on the vehicle.
Sure. Gentlemen, thank you. We have run out of time. It's 5 minutes beyond our scheduled time, but this has been a fascinating panel discussion, and I hope all of you enjoyed being part of it as much as I enjoyed moderating it. Thank you once again. Thanks very much.
Thank you.
Thank you, everybody.
Thank you all. Really a great experience.
Yeah, quite interactive session.
Wonderful.
Thank you all.
Thank you, gentlemen. Thank you very much.